Hi everyone, and welcome to a lesson on Postfix. So first things first, we're just gonna go over the following topics. We're gonna go over converting infant to postfix, how to evaluate a postfix expression to get a number, and expression trees. What are they, how to get one, so on and so forth. So a quick reminder, this is infix notation. Notice how the operators are in between the operands. So just some vocab words that we will be using. An operator is like the plus, minus, divided, and the operands are like the actual numbers. They can also be letters, like if you're using variables, like a plus b, a will still be an operand. Postfix, we're going to see that the operators are post the operands. Wow, crazy how that works. This is actually much computational faster to evaluate. So that's the use case for postfix. Now, how do we convert from infix to postfix? Well, we're going to use two things. We're going to use a stack to order the operators and a queue for actually holding the postfix forms. So whatever's going to be in the queue is going to be like the final answer. You're building the final answer in the queue. So again, I'm going to repeat that. A stack orders the operators and a queue holds the postfix form. Hint, hint. You're going to see that down here, I have priority of operands. So you can just use good old PEMDAS for that. But like, if you see a plus sign versus a minus sign, you know you're going to subtract first. If you see a divided instead of a minus sign, you know you're going to divide first. I just wrote them out for you, but you can just think of it mathematically, like what would go first. So when I say that like a multiplication sign has a higher priority, for example, than a minus sign, what I mean is that in a math expression, the multiplication sign is going to go first. It has priority, so it's going to go first instead of the minus sign. Notice how end has least priority and how a closing parentheses that also has the least priority. So here are some steps written out. I'm not going to read this, but if you like reading, here they are. So let's go through one example. So here our letters are our operands, so A, B, C, D, E. Our queue is going to keep track of our postfix expression, and a stack is going to order our operators. First thing we're going to do is going to push the end token onto the stack. Second thing we're going to do, we're going to look at the A. We notice it's an operand, and just when you see an operand, just immediately push it to the queue. Don't even worry about the operator stack. Operands, queue. Simple enough. Now we have a multiplication sign. Now what we're going to do with an operator is we're going to go to our stack. Next, we're going to check the top of the stack, and we're going to ask ourselves, does whatever is on the top of our stack, does that have a higher priority? In our case, it's the end. It's the end token. So we ask ourselves, does the end have a higher priority? The answer, no. So we're going to push our multiplication sign onto the stack. B, we just push it onto the queue like normal. Now the plus sign, we're going to do the exact same thing. We're going to look at the plus sign and we're going to wonder, does the multiplication sign have a higher priority? In this case, yes. If you have 5 times 2 plus 3, we know that the times is going to go first. So that means the multiplication sign has higher priority. Because of this, we're just going to pop the multiplication from the stack and we're going to push it onto the queue. So we pop multiplication sign from the stack into the queue, and we're just going to push the plus sign onto the stack. So this is how we get the situation. Multiplication sign now in the queue, and plus sign now in the stack. When you see an open parentheses, immediately just put it onto the stack. Don't worry about it. C, into the queue. Minus sign. Does the open parentheses have a higher priority than the minus sign? No. If you see, in this case, open parentheses has like an extremely low priority. So minus sign has priority over that. D, push it to the Q. Division sign. Does the minus sign have a higher priority than the division sign? In this case, no. So we're just going to normally push it onto the stack. We're going to see an E, right? Push it onto the Q. That's just an operand. Now, when we see a closed parentheses, what we're going to do is we're going to pop from the operator stack until we find that open parentheses. And we're going to push everything we pop from the stack into the Q. So we're going to pop the division sign and the minus sign, put into the Q, right? Notice how we also got rid of the open parentheses, but in Postfix, you don't have open and closed parentheses because they're not really necessary. You know what order to evaluate them by nature that the operands are always, the operators are after the operands. So now that we've reached the end of our expression, we're just going to pop the stack until we reach our end token. And whatever is left in the operators, we're just going to put it into the queue. And there we go. And we would also pop the end token. Okay, hopefully that made sense. Let's move on to postfix to number. So from evaluating postfix to number, we're going to use a stack. Okay, postfix to number, stack. So let's take this example right here. So here's some more words if you like reading. So first I'm going to do, again, with the same thing with an operand. If we see an operand, we're just going to push it to the stack. Just normal. So we see the 5, push it to the stack. We see the -2, another operand, push it to the stack. We see this multiplication sign. When we see a multiplication sign, we're going to do two things. We're going to pop 2 items from the stack. We're going to evaluate that expression, and then we're going to push what our result is back onto the stack. So let's take a look of how that look. Multiplication sign. We're going to pop 5 and -2 off the stack. Next, we're going to evaluate the expression. Notice how you go with from bottom to top. So how it was before, you had 5 and then -2. You're going to do 5 times -2. The order does matter. We're going to get a -10 in that case. And we're just going to push that result onto our stack. -10. I'll fix my answer in the bottom left corner from 10 to -10. Okay, next you're going to see there's a -7. I'm going to push that onto the stack, like next 40. Next 8, we just push again. Division sign, again. We're going to pop the top 2 things from our stack. We're going to do the expression, so we're going to get 40 divided by 8. 40 divided by 8 is 5, and we just push that onto the stack, that result. Minus sign, same exact thing. -7 minus 5 is -12. We push that answer to the stack. Now we're going to do the plus sign. We know -10 plus -12 is -22, and we push that onto it. We reached the end of our evaluation, and now we know the answer is -22. Okay, next let's talk about expression trees. So expression trees. When you have an expression tree, it looks like the following on the right. Notice how any operators have 2 children, and the operands are always the external nodes, so the bottommost. They never have any children. That's an important thing to know. And it makes sense because how we kind of look at this is let's see this B and C node. B and C, we're going to kind of look on top, and we notice it's a multiplication operator. So we know we're going to do B times C. Okay, so that's going to be B times C. Next, we see there's an A, and A is kind of onto its sibling. We see that there's a B times C. So we know we're going to do A. We look at whatever operator is telling us to do. And then so we do A plus B times C. And you keep going on that, so on and so forth. if you want to get the actual post-order expression from an expression tree, so go from expression tree to post-order, we do post-order traversal. So post-order traversal gives us a postfix form in an expression tree. I'm going to repeat that. A post-order traversal gives us a postfix form when given in an expression tree. So you can prove that to yourself. I gave you the answer right here, ABC times plus DEF plus times plus. If you don't know what post order and in order is, I recommend you to look through another one of our videos about trees, so you kind of know, are able to perform these operations. So we can also go from a post order expression and convert that into an expression tree. To do that, we're going to do two things. We're going to start from the very end. If there's an operator, we're going to basically fill it in with a node with 2 pointers. If it's an operand, we're going to fill that in from right to left. Let's just see an example. I think that's just easier. So this plus sign is an operator. So because of that, we're going to create a node with like 2 pointers. And we're going to start filling this in from right to left. So next, we're going to have a minus sign. And since there's like a right pointer available, we're just going to put it onto there. And again, a minus sign is an operator. So we're just going to create a node with 2 more pointers. Division sign, same exact thing. Now we're going to see that there's an E, and the E is an operand. So we're still going to fill in from right to left, but we're not going to add any children to the E. So in this case, there's the E. D, exact same thing. No children, but still start filling in from right to left. Yes. C, fill it in right to left. Multiplication sign, we added to that remaining like little pointer, but we know it has 2 children. So we create a node with 2 children. B, and then A. That is it. Good luck on your test. I would highly recommend for you to go through and just make sure you can build expression trees and kind of evaluate expression trees. One thing I will say is kind of know like your height and depth. So what is the height of this tree? You know, in the test, you may be asked to like, or you probably will be asked, given a postfix expression, make a tree. And then we'll ask you different questions about that tree, like what's the height, you know, how many nodes are there, so on and so forth. Yeah, good luck on your test, and have a great day.